What an array is it's a list of values, a list of elements, a list of numbers, a list of words, a list of structures. We haven't talked about structures, but a structure is a data type that you define. Stored contiguously in memory. It's a variable that can store multiple values. And the values are located in adjacent memory locations, which makes it really easy for the program to find them. There's a value at position 0, there's a value at position 1, there's a value at position 2, there's a value at position 3. It's very fast for the computer to run through that list and do stuff with them. The way you declare an array is the way we've been declaring our variables. You give it a data type and a variable name, and then you use square braces. And you put the number of elements in that array in the square brace. So here we go. If we created this variable, it creates a variable called tests that could hold 5 elements. Now, arrays, and this is why I gave assignment 0 rather than assignment 1. Computers start counting at 0. So this element is actually element number 0. That element is actually element number 1, 2, 3, 4, and so on. So this is the data type. That's the name of the array. This number in the braces is what's known as the size declarator. It's just the size. You can call it the size of the array. It is saying that the size of the array is the number of elements times the size of each element, which is more strictly true. But if you ask me what this 5 was, I would say it represents the size of the array. It's the length of the array. That's a better term for it. It can hold 5 elements, 0 through 4. So the size of the array, according to them, is the total number of bytes allocated for it. Since since an int is 4 bytes long, this is 4 times 5 for a total of 20 bytes. If this was a long is 8 bytes rather than 4 bytes per number. So it would be 5 times 8 rather than 5 times 40. Or here their example is for 10 elements. 10 longs would be 10 times 8 for 80 bytes total size of the array. Quite often it's a good idea to use a named constant to declare the size of your array. It eases program maintenance. You can stick that constant definition in a header file, and then if you ever need to change the size of your arrays, you can just modify that header. Accessing array elements. That is element number 0. That's element 1. That's element 2. That's element 3. That's element 4. So, popping open a recent project. I should just paste in my boilerplate, but here we go. This particular one is not going to need CMath in the least, but whatever. I can delete the CMath. Okay, so I'm going to declare an array of 5 strings. So I give it a data type, I give it a name. I'm going to call the array colors because I'm going to put 5 colors in it. And then I specify the size. That creates space for 5 different strings to be held. I can make the first one, red. The second one, orange. The third one, yellow. If I was going to do the colors of the rainbow, I probably should have more than 5. Roy G. Biv, whatever. Colors 3. That's the 4th position, green. And colors 4, blue. There we go. We have created an array. It's just a list. It's just like an apartment complex, except the apartment numbers start at 0. Red lives in apartment number 0, orange lives in apartment number 1, yellow lives in apartment number 2, green lives in apartment number 3, and blue lives in apartment number 4. We can make a loop that would print out all of those colors. For int x is equal to 0, because that's a starting point. Now I did not create a constant to hold the size of this array, so I'm going to do that. Constant int colors size equals 5. Now I can use that in my for loop. For x is equal to 0, while x is less than the size of the array, x plus plus, I could output out to the screen the element at position x. Maybe I'll also write out x itself. Like that. Okay. So what this will do is x will iterate through the array. We're familiar with the for loop syntax now. X will equal 0, 1, 2, 3, 4. It'll stop at 4 because once it hits 5, it exits the loop. And so it's going to print out red, orange, yellow, green, and blue because x will iterate from 0 to 4. Print out each one of those. Put my system call at the end. And go. There we go. Red, orange, yellow, green, blue. So say down here, after we've printed those values out, we want to change the one that says green to a different color. What's a different shade of green? Mauve? No, that's kind of a purple. Ochre. I don't know. We're going to change it to the word violet. That's not rainbow order, but who cares? How would I change this word to violet in the list? What would I need to do? Which element do I need to change? Yeah, I'm going to reassign that element to say violet. So colors is equal to, colors 3 is equal to violet. Now if I printed the list out, instead of printing what it did, it would print the same colors, but green would no longer be in it. I'm just going to copy and paste that for loop. And I'm going to put it all on one line rather than split up like it was. Alrighty. There it goes. Red, orange, yellow, green, blue. Red, orange, yellow, violet, blue. Kind of get it all on one page for those who are typing it in themselves. Anybody want this on the screen longer, or is that good enough? Nobody said they wanted it on the screen longer. I can always print it out for you if you want. All right, so that's how you access the elements in the array. Notice that the last element is at position n minus 1. If this array is 5, you can only go out to 4. If you try to go out to 5, you'll get some kind of error, or you'll cause some kind of a problem. That's called going past the end of the array. It's also sometimes called a buffer overrun in a different syntax. And a lot of hacking efforts are done by triggering buffer overruns, writing past the end of an array. So array elements can be used just like any other variable. If you set tests 0 equal to 79, then you could use that anywhere any other int was used. You could cout it, you could cin into it, you could use it in math. However, you can only address it by individual elements. You can't say C out, oh, and I want to see what the entire array is. Some languages let you do that. However, in C++, you can only print out, you can only access one element at a time, unless you write a special awesome function for doing that. This program asks for the number of hours worked by 6 employees. It stores the values in an array. I think we can write a better program than this. We're going to declare 2 arrays. One is going to be called name, or E names for employee names. It's going to be 5 long. And then we have float for E salary, E salaries, E wage. There we go. Let's define an int, a constant int that to follow the size of our arrays. I'm just going to call this the E size, number of employees, whatever. And everywhere I was going to put 5, I need to put E size instead. And the reason you do that is because you need some way of knowing where the end of the array is, so that you don't try to access element number 6, 7, 8, 9, or 10, like in a for loop. So it's a good idea to hard code it as a constant. And that way you don't put 5s all throughout your code, and then later on if you decide you wanted to hold 10 employees rather than 5. Alright, so now let's write a while loop or a for loop. For int x is equal to 0, x is less than E size, x plus plus. Let's tell the user enter employee first name and salary. So we're going to let them enter the first name into E names at position X. And then we're going to let them enter the salary into E wage at position X. So as X counts from 0 to 4, we'll fill in name number 0, wage number 0. Then we'll come back in and we'll fill in name number 1, wage number 1, and so on all the way through. Now, why would you do that? Well, we could print out tables of wages and names. We could add up all the wages, to calculate a total monthly expenditures for the company. Let's firstly just write out a little table. We're going to need another loop. X is equal to 0, X is less than E size, X plus plus. C out their name at position X, element number X, followed by a tab character, \T, \/ is the one above the enter key, followed by their wage, E wage at position X, followed by an end of line. Okay, that might do it. It's going to do that business about colors first, but after it does the colors, it's going to start asking us for names. Enter employee first name and salary. First name is Jeff, salary is 10. Enter employee first name and salary. Bob, 20. Carol, 15. Sam, 25. And Sue, 12. And there we go. Then it prints it out in order. Jeff, Bob, Carol, Sam, and Sue. Now when we were asking them to enter the employee first name and the salary, it'd probably be nice if we also printed out the value of variable X. So it'd say enter employee number X, employee 1, 2, 3, 4, 5. Because otherwise it just kind of looks like, an error of some kind. Why is it asking me again? I just typed it in. But you get the idea. If you have two arrays like this, I guess I could do it here. We had one called names. We had one called wages, whatever, variations of it. We had Joe. We had a salary of 15. And we had Bob. Had a salary of 12. This is at position 0 in each one. You cannot possibly see these. That's a little better. Joe is at position 0 in the names array. His wage is 15 at position 0. So to get that name, we would do name position 0. And here we would do wage position 0. Bob is the next one in the array. So Bob is at position 1. This is known as the index. He's at index position 1. The element of position 1 in the name array is Bob. He has a salary of 12. So wage at position 1 is 12. We have two different arrays like that or more that are thematically united by these numbers. Element 0, 0, element 1, 1. Those are called parallel arrays. You know, maybe we need an array of first names, an array of last names, an array of job positions, an array of how many hours worked, and an array of what their hourly salary is. That would be 5 different arrays, but they would all be linked by their index position. Element 0 in each array all refers to Joe. Joe Sampson works 30 hours a week at $15 an hour. You know, all that information is all thematically united by the index number. So that's what's known as a parallel array. Don't recall if the PowerPoint calls it that. You can use a literal to specify a position in the array, like when we were doing with colors. You know, we said color parentheses 3 is equal to violet. Or you can use a variable, like we've been doing with our for loops. Same way. If I is set to 5, then we're changing element number 5 in the array. So starting at 0, 0, 1, 2, 3, 4, 5, 6. It's actually the 6th element in the array. Using a loop to step through an array. Here we go. This should look familiar now that we've typed in that code a couple of times. For int count is equal to 0, count is less than array size, count plus plus. So that counts from 0 up to but not including the size of the array, so that we're going to go, in this case, from 0 to 4, and we print out each number. Or actually, this is assigning 99 to each position in the array. A local array is one in which you define your array inside a function, including the main function. The values are uninitialized, meaning you don't know what they contain. I'm going to come up here and demonstrate what I mean. I'm going to create an array of 5 doubles. I'm just going to call it, no, 5 doubles. I'm going to call it DA for double array. I'm not going to assign any values to them, but now I'm going to use a for loop to print them out. For double D is equal to, no, this is a counter. I'll just use X again. X is less equal to 0. What should the second part be? I'm going to iterate through this array. I want it to go from 0 to 4. So what do I want this second part of the for loop to be?
Less than 5.
Yeah, less than 5. And then I'm going to see out DA at element X, followed by an end of line. Then I'm going to do a system pause so that we don't start printing out colors and asking for wages. And you might think it'll all be zeros. Yeah, it seems reasonable, but it's not what happened. Whoops, made an error. Oh, because I already have the program running. Can't compile it. Let's find out what's really in those spaces, which we wish were zeros. They are not. Look at that number, negative 9.25 times 10 to the 61st power. That's a pretty weird value. That's a very specific value in this case because we compiled it and ran it in debug mode. If it was compiled for release rather than debug, then we wouldn't even be able to predict what values were in those. So that's invalid information. If you want to, you can initialize all the values of the array to 0. And you would do that with a for loop, like this. Same idea, x is equal to 0, x is less than 5, x plus plus, and then you say that element at that position, dA at element position, dA sub x, is equal to 0. That will wipe them all out.
So by default it's that large negative number?
Right. Especially if you're running in debug mode, it's equal to that specific value, but if you're not running it in debug mode, then or compiled in debug mode, you have no way of predicting what's in that number. All you know is that it's garbage. So this iterated through it and it reset all the values to 0. You don't have to do that if that is not declared as a local variable inside a function. If it was declared as a global outside of all the functions, then it would already be pre-initialized to 0. Comment this out. It'll already be set to 0. There we go. Have we talked about the difference between local and global variables? Local ones are the ones that are defined in a function. Global variables are defined outside of a function. Why do you declare a global variable? So that it can be accessed by more than one function. What if I wanted a function called printDA that had this code in it? Well, I could do that. I just come up here, declare my new function. I'm going to call it printDA. It's going to have a for loop that prints out that function. Then anytime I want to print the DA variable, print the DA array, I would just call that function like that. We would not be able to do that in that fashion if this was not a global. Because if this was declared down here like we normally do, then it doesn't know what in the world DA is. How would we fix that, by the way? If we were dead set on not making that a global variable, which is a very common thing. Global variables are actually far less commonly used than local variables. What would I do to fix that?
So DA equals something?
Well, I need to pass in DA into this function. So I could come up here and do double DA like that. Oh, I declared that syntax wrong. That goes after it. That's the difference between Java and C++. Okay, we're saying, by the way, this function accepts a parameter. That parameter had better be an array of doubles. Now it'll work just as well. So you could either pass the array in as a parameter, like that, or you can make that variable a global. Put that out here. We don't need to pass it in. Global variables are considered bad programming, poor programming, especially anymore. But they're worth knowing about. You will run into them. So let's make a few notes. If I was going to declare an array of 10 ints, what would the syntax be? Firstly, I'm going to define a const called size, which is the size of the array. But now that I've done that, I want an array of 10 ints called IA. Help me type this out. What would the very first thing be? Yeah, it'd be int. Then what? It'll be the name of the array, IA. And then what? Yeah, we need our square brackets, and in there we need the size of the array, the length of the array. That would do it. And then we could start filling in values. IA0 is equal to 100, IA1 is equal to 200, and so on. IA2 is equal to IA0 plus IA1. That would work. We want to increase the value of 2 of IA position 2 now, so we could do IA2 plus plus. That would take that value and add 1 to it. See, in each case, we're just treating it like it was a different variable, because in effect it is. They just all happen to share one name, and they differ by their position. Two arrays linked by their index values are known as parallel arrays. You could do months and rainfall, for example. How many months are there in a year? There are 12. So const int months equals 12. Then we would declare a list of months. And we would declare a series of doubles for their rainfall. And then month at position 0 could be January. The rainfall for January was 10 inches of rain. Something like that. Except that should have been rainfall. And then we could do the same thing for February. Month number 1 is February, and it had a different amount of rainfall. Had 5 inches. There we go. These are thematically linked. Every element at position 0 has to do with January. Every element at position 1 has to do with February, and so on, all the way out. What would the number be for December? What would the month number be?
11.
Yeah, it'd be 11. Very good. Month at position 11 is equal to December. And we had a really high amount of precipitation because it was a white Christmas. And so we had 30 inches. There we go. Whatever. So if the size of the array is called n, then the largest index you can address is n minus 1. For example, int IA at position 4, you can access elements 0, 1, 2, 3, 4, like that, if that is 5. There is no bounds checking in C++, meaning that the compiler doesn't know how large that array is. So if I come in here, this array was 5, right? What happens if I try to access element number 6? If I decide that element number 6 is going to equal 100 for whatever reason. That's not a syntax error. It thinks that's perfectly fine. It even worked right. Didn't generate an error. It's surprising that it didn't generate an error, but it didn't. But that can cause problems. Let's say that we had a string after that. I'm just going to call it S for string. We change element 6. Well, let's just change element number 5 because we know that 5 is out of bounds. 0, 1, 2, 3, 4 are the only ones that work. Now let's try printing out DA at position 5 and also that hello string. And let's see if that works. We might see that this data is corrupted. We might not. Yeah, look at that. It doesn't say hello anymore. It says Y at 0. Could you predict that by looking at it? Absolutely not. This data is corrupted. No longer does it say hello. Why did that happen? Because if there's places for 5 doubles, it's effectively like allocating this. DA at position 0, DA at position 1, DA at position 2, DA at position 3, DA at position 4. And then that was the last one. But then we assigned at this position right here in memory the value 100. We overwrote this position in memory because we went past the end of the array. It tromped over this variable. And it may have tromped over what's after that as well. That's why buffer errors are so commonly exploited by hackers, because you can write past the end of an array and you can corrupt other data in the program. You may even be able to corrupt memory that is owned by the operating system rather than the program. Now, most modern operating systems don't allow you to do that, but they used to. So you have to do your own bounds checking. You need to make real sure you're not accessing past the end of the array. And if you're hard coding numbers like that, it's real hard to do bounds checking. But in this case, accessing from 0 to 5, we can do that. It'd be even better if this 5 was declared as a constant. Const int d size is equal to 5. And then everywhere I used 5 in this particular application, in this particular meaning, I would do that. That would stop me from accidentally reading past the end of the array. If this array is 5 and then I try to print out more than 5, what happens if I try to print out 10 elements? Let's see what happens. The array is only 5, but we're telling it, hey, I want to see what's at element 6, 7, 8, 9, and 10. There we go. It's printing out garbage. It's not really garbage, it's just that this variable here that says hello, well, somehow, if red is a double, it looks kind of like that. So this is data that we're not supposed to be able to access, but the C++ compiler has no problem letting us access it because it's not part of the array. These are the elements that are part of the array. The element is 5 elements long. Anything after that is data elsewise used in the program. Other languages like Java and Python do not allow you to go past the end of the array. They flag it as an error much more violently than this one does. The program will actually stop running. This one went ahead and ran. It just did some bad stuff. Sometimes C++ will catch it and throw up the debugger, letting you know that you wrote past some data that you shouldn't. But you can't depend on that. So whenever you use a value as an array, C++ compiler does not check to make sure it is a valid subscript. And at runtime, nothing checks it either. So you can use subscripts that are beyond the bounds of the array. You better not, but you can. It'll cause problems, though. This following code defines a 3-element array, but then writes 5 elements to it. The size of our array is 3, but then we have a for loop that fills in 5 values. That's bad. It goes past the end of the array. So you have to be careful not to use invalid subscripts. If you do that, you can corrupt memory, you can crash a program, you may even lock up the computer. It can cause elusive bugs. Sometimes the program will seem to work perfectly, and then other times it won't. Then there are off by 1 errors. Off by 1 errors are when you should be referencing something at element 0, but you call it element 1. So for example, in our months, where did our months go? Here we go. What if I thought, well, the first month is 1. So I'm going to fill in month 1 and say that that's January. Well, that's an error. You're leaving element number 0 empty, and then by the time you did month 12 and set that equal to December, you're writing past the end of the array. You're corrupting memory. So that's what's known as an off by 1 error. You should have been starting at 0 and going up to 11, but we made the mistake of thinking that we were going to go from 1 and go to 12. Now, why might you be tempted to do that? Well, our brain works that way. The first month is January, the last month is December, there are 12 months. That's the way our brain works. And more importantly, that's the way that the user wants to see it. The user doesn't want to see, oh, by the way, month 0 is January, month 1 is December. If they're typing in a date, they're going to be typing in a number that represents 1 for January and stuff like that. So you have to figure out how you're going to modify that to work with an array. You probably take what they type in as a month and then subtract 1 from it. So it'd be 0 to 11 rather than 1 to 12. CI1 error is starting at array index 1 rather than 0. Array initialization. You can initialize your array like this. You can use curly braces, and then you can fill it full of data right then and there on the spot. So when I was doing those colors, I could have done it like this. Instead of saying colors 1, 2, 3, 4 like that, I could have did this. The first color is red. The second color is hot pink. The third color is mauve. The fourth color is black. The fifth color is white. There we go. Now we've initialized that array. We don't need these things. And now if we print them through, it's going to say red, hot pink, mauve, black, and white. Now quite often you won't know in advance what your data is. But sometimes you will, like the name of the months. So if I run this now, and I print those months out, or those colors out, it's going to say those colors instead. Well, it's got a pause in it anyways. There we go. Red, hot pink, mauve, black, white, and then after it changes one of them to violet, red, hot pink, mauve, violet, white. Our months example, we could have declared the months array in the same way. Instead of saying month 12 like that, we could have done is equal to January, February, March, April, and so on. May, June. If only there were fewer months in the year. July, August, September, October, November, and December. Like that. There we have created an array of 12 where the first element, the one in position 0, is January, which leaves this stuff unnecessary. We don't have to fill these in anymore. We don't have to do that. We don't have to do that. We don't have to do that. Those are already set. Here's an array for the number of days in a month, not counting leap years. January has 31 days, February has 28, March has 31, April has 30. 30 days, half September, April, whatever, you know. December has 31 days in it. So he created an array full of 12 ints and put the number of years, I should say she, I think a woman authored this text, could be wrong. Then that way you could print out the number of days in each month. It would look like this. Month 1 has 31 days, month 2 has 28, month 3 has 31, month 4 has 30, month 5. And it'd be even cooler if we printed out what the name of the month was, which we could do with another array. Let's go ahead and do that. If you have a program up and running, go ahead and go to the top of it. Let's declare a constant called months. Set it equal to 12. And we're going to create two arrays. Months, which has the names, and then days, which has the days in each month.
What should we call this project?
Oh, whatever. Months. Yeah, just call it months.
Will this be an in-class assignment?
Pardon me?
This will be an in-class assignment?
Yeah. We'll make this part of our in-class. Okay, so we need a string to represent the names And let's go ahead and fill those in. This is tedious, but inside curly braces, make a list separated by comma of months' names. And I like 3 letters. If you don't want to do 3 letters, if you want to do the entire name, that's fine. Sneak a peek. I think I have that wrong. Wish I had a better memory. Okay, I do have that wrong. And then one more variable called a rain, which will represent the rainfall or the precipitation for that month, which we may as well store in a double. A shortcut for initializing every value in an array to 0 is to do what I just did there. That sets all of that particular array to 0. Not intuitive, but it's a nice shortcut, so they put it into the language. Now we're going to have 2 loops. We're going to have one loop which asks the user to enter the rainfall for each month. And then after they do that, we're going to print out the rainfall, the total rainfall, and the average rainfall per day. That's what this days array will be for, because some months have more days than others. So to calculate the average, we'll need that. So the first loop, we'll make it a for loop. Let's use our x as our counter again. Alrighty, that's our month for entering the data. Not our month, our function, our code, our for loop. Let's write another one for displaying it. Same idea, x is equal to 0, x is less than months. Get real used to that syntax. Whenever you're dealing with arrays, you're going to do that over and over again. So let's see out the month name. Followed by a tab. Followed by the rainfall for that month. Followed by a tab. Followed by the rain divided by the number, I'm going to put this on the next line, by the number of days in that month, followed by an end of line. And since I have other junk in this, which y'all probably don't have, I'm going to put a system pause at the end of that, which you'll want in your program anyways, else you won't be able to see the output. All right, before we go further, I'm going to test mine, make sure it works before I wander around and see how y'all are doing. In a rainfall for January, 10, 20, 30, 20, 10, 15, 20, 25, 30, 25, 0. November was real scarce, and 31. And there it goes. It prints the total rainfall, and then it prints the average. And we could put some headers on this little thing in order to make it look nicer, which I will do. So above my second for loop, I'm going to see out the month, followed by a tab, the total rainfall, followed by a tab, and then the average rainfall, followed by /n. Be thinking about how would you calculate the average rainfall for the entire year. Just kind of be pondering that. I walk around and tell people that. Oh, I'm sorry. How about I print it out for you? Remember, you can throw shoes or socks or anything at me to get me to slow down. this before that loop?
Oh, I have, but
Tell me what it looks like. Why is it underlined?
I don't know, but it's gone when I put it in here. All the buttons say, whenever you're about to do this, I have to do that too.
Oh,
Well, oh, there goes everything.
I don't know why that one has gone. Oh, just because it's same color. Yeah, okay. Into file review. You just need one more brace.
Oh.
Yep.
My CIs are still weird now.
What's the error it's complaining about? Yeah, and it did that in other places too. Okay, go up here and under or above CMath, do pound sign include string. I don't know why this is necessary, because obviously string actually worked, but okay. I think that made our errors go away. All right, try it out, just enter a series of numbers. All righty. How could we possibly go through the list of rain to calculate an average rainfall? Not per month, which we've already done, but the average for the entire year. Or how would you create a total for the entire year?
Total equals plus, and then whatever the last one was.
Yeah, you could do one of two things, and one would be kind of obnoxious and one would not. Don't type this because this is the obnoxious way. You could do this. Total is equal to the rain from month 0 plus the rain of month 1 plus the rain of month 2, dot, dot, dot. Now that's kind of tedious, right? I wouldn't want to have to type in 12 of those. We could, but what if the array was 1,000 elements long? We would not want to do it that way. Instead, you want to create a for loop or a while loop that will calculate the total. So we've initialized, this is our tally variable, our sum variable. We've initialized it to 0 so we can start adding stuff to it. For, and x is equal to 0, x is less than the number of months, x plus plus. Our total is going to equal total plus the rainfall for that month. Or we could just do plus equals if we like concise syntax. Now we have a total. How would we calculate the average? We have a total, right? What's the average going to be? Yeah, divided by 12 or divided by the number of months. Average is equal to total divided by the number of months. And we could print those things out. C out total rainfall divided by, or followed by the total, and then C out average rainfall.
just in time.
Yes,
Come look.
I was hoping you'd come by. When I actually ran the actual debugger, I thought it was this line right here.
Something weird going on here. Not X comma months, it's X less than months. It just didn't get shipped.
Thank you.
So I don't even know what it was doing there. I'm surprised it didn't flag that as illegal syntax. But that would be better behaved.
So,
A lot of rain that month.
oh, look at that.
Cool, yeah.
Thank you.
Sure.
All right, why don't we take a break? Be back at 8:35. Mm-hmm. Well, yeah, that's fine, but that's not a program. But that would do it,
So it's 5 here. So you still what?
Well, you're gonna have to, I actually want it to be a program.
Upload it?
And yeah, you're just gonna need all that int main and stuff.
Int main.
And you're gonna have to initialize x to its proper value. So int x is equal to 0 or whatever.
Okay.
Yeah.
Okay, fine. Good question.
Yes, sir.
This one running properly. I just copied something over, and I was wondering if it's running properly or not. That's supposed to be what it looked like?
Yeah, yeah.
Okay.
And so for that student,
Just like that? That's it for the PowerPoint.
right. Something wrong with that one. Number of students, let's go look.
I put 1.
That would be why.
Because
Right.
the
So,
PowerPoint doesn't define what it is.
right. So make it 3. You could enter data for 3 students.
Oh, okay. Drop that.
That's bizarre. Is it, may not be recompiling it because
So redo it to do a for loop as well as a while loop. Yeah, yeah, just to make sure you can do both. I mean, even if it's not part of the assignment.
Oh, okay, all right, yeah.
Okay, the homework said enter the code. Guess I should wait for everybody to come back. Unfortunately, there's not enough here to actually get it to work. We're going to need a few more lines of code in order to get it to work, right? Because it doesn't have main up at the top and it doesn't define these variables. So when we get back, we'll do that. The homework assignment, homework 7, which was due never. All right, we'll make it due on Sunday. Give you ample time, but there's going to be another homework assignment to go with it.
Are we done with this in class?
I think so. So the homework assignment was, part of it was enter the code on page 65. But it didn't mention that that's not a complete program.
Well, you can assume that by looking at it, but trying to add like the loops and everything,
Yeah,
I could get mine to work.
okay,
She's not alone.
okay. We'll work on that together. So how would we get this to work? We're going to need a couple of things. And yeah, you could figure it out yourself. You just need to declare a variable called num students and num tests, and give those values like greater than 1. You know, 3 students and they each have 3 tests, and put that inside a main with a pause at the end, and you should be good to go.
Yeah, mine would work. I just couldn't figure out the average. It wasn't working for me.
Okay.
And mine had too many errors.
You give it points, but it wasn't an actual average.
Things total and average as well.
Yeah, some pretty decent text if you want to pull it from somewhere.
Let's see. So this part wasn't working for you?
Right, like, if I put all 50s, yeah, they'd get an average of 50, but then for the next student, I could do like 0, 50, and 100, and average would be what it should calculate to be.
So. I'm surprised this worked. Okay, we're asking for the number of students, we're asking for the number of tests. You know what I would do is I would make the number of tests only be asked once rather than on a student by student basis. That may be why our average is coming out a little bit odd.
Okay.
I can't say that to be sure, but
Put it
let's
before.
let's try that out. Let's run it.
Yeah, that was different from the PowerPoint.
Cause you probably edited it from before.
Yeah.
Well, mine worked, I didn't edit anything from the picture.
But the PowerPoint doesn't have a main and stuff like that, does it?
Yeah, you just put the main and declare the num student, num test, total and average.
Exactly,
and-
right. That's what you need to do. But he's prompting the user to enter the number of students and the number of exams, so he added a little bit of functionality.
Did you not have to? Because I couldn't get mine to do anything.
You do have to assign those values. You don't have to ask the user for them.
Oh, okay. So ants number of tests equals like 4 or something.
But I want to test it the way you had it first, if I ever get it to work. All right, enter the number of students, 3. Enter the number of tests. The first one's going to be 2. Enter the number of tests. The next one's going to be 3. 20, 20, 30, yeah, 20. Okay, if we enter 2 tests, the average 15 should have been 25. So let's go look to see what's going on with that. Well, let's print out the total, and then let's print out the number of tests so we can compare. Total. Average. Or num tests. Just a sec. Oh yeah, yeah. Okay, take a look at this. The syntax isn't right. It's actually plus equals. It will be a lot better behaved now. Good debugging catch on that one. 3 students. And then the number of tests. 3. Billy's into the test number. This is test number 1. Okay, enter score number 1. 10, 20, 30. The total is 60. Okay, that I think fixed it.
Okay.
The only changes I would make. You don't even need to do that. You don't need to change anything. I would have been tempted to move this code up here, like that.
But if I was going to change it, I'd just set a test number at the top. Like.
Or you could do that. Yeah, you could hard code a test value rather than prompt the user for it. So yeah, if you're going to get this to work, you're going to need to declare your variables that are on there. Give them some reasonable values, like 3 students and 4 tests or something like that for the number of num students and for the number of num tests. Okay, so going back to loops. Loops are important for the processing of arrays. What kind of loop to use? We've learned 3 loops. We've learned while loops, we've learned do loops, and we've used for loops. Do loops you want to use if you need the code in the body of the loop to execute at least one time. Because remember, a do loop is post-test, so it executes the body of the code before it gets to the test. So you know that that code inside the braces will always be executed at least once. And if in your mind that's the way you want your loop to work, use a do loop. And remember the syntax of the loop. It's do, and then some code between the braces, and then it's while, and then you put your condition, and then you put a semicolon. It's the only time you use a semicolon in conjunction with a loop statement is in a do loop like that. Obviously it's going to be a lot longer than that because you're going to have, you know, several lines of code between the braces there. The for loop. For loops are used when you know you're going to be iterating through a specific range of values that you can predetermine. You know, if you know you're counting from 1 to 10, or you know you're counting from 100 to 1,000, or you know you're stepping through every element in an array, you want to use a for loop. So the for loop is best used for situations where the exact number of iterations, and I would say the range of iterations, is known. So for like our months, we knew we were going to go from 0 to 11, so that was a good use for the for loop. And then you use a while loop in cases where this one and this one don't seem to fit. So I would have reversed these. I would have made that one first, that one second, and then a while loop last. So let's tack that into our notes. When do you use a do loop? What's the syntax of a do loop? It's do something while condition semicolon. Use when you want the body of the code, the something here, to execute at least one time. If it's okay for that not to execute, you wouldn't do a do loop. Then a for loop. What's the syntax of a for loop? We're getting real good at this. We've done this one. For, you initialize your variable, you set the limit for it, and then you increment it. Use when the number of iterations, or the number and range of iterations, is already known. Then the while loop. While condition, do something. Use in cases where do and for do not seem to work. Now, truth be known, you can always use a while loop. There's nothing that a for loop or a do loop can't do that a while loop can. But this is awfully concise syntax for expressing what you want the loop to do, so it's a nice way of doing it. And in order to execute a pre-test loop with a while, you'd have to be very careful. Excuse me, a post-test. So those are our 3 cases. Let's just put 3 loops here, 3 loop types. 1 is the do loop, 2 is the for loop, 3 is the while loop. Nested loops. Nested loops are when you have outer loops and then you have an inner loop. For example, if you were going to print a table, a multiplication table of some kind, you'd want to print a series of numbers, and then you'd want to hit the return key and print another series of numbers, and you'd want to hit the return key and print another series of numbers. So in one of our little programs, let's just make a little loop that will print a box that is 10 wide and 4 long. So I'm not going to start a new code to do this. You could just stick this in your rainfall or whatever. Int length, or constant length, int length is equal to 4, int width is equal to 10, and now we're going to use a nested loop in order to print out a box made of asterisks. 4, int x is equal to 0. Now let's make it C for column. C is equal to 0. C is less than the length. Excuse me, C is less. Yeah, I'm botching this one. For row is equal to 0. Row is less than the length. Row plus plus. That's our outer loop. Now we're going to nest an inner loop inside it. For int C is equal to 0. C is less than the width of it. C plus plus. Now we want to see out an asterisk. And then we want to, after that loop is over with, hit the return key. So we're going to see out an end of L. And there we go. It's 4 rows by 10 columns. And you can see that it's an outer loop and an inner loop. This is called a nested loop, just like Russian dolls nested inside each other. We could do something more useful than just printing asterisks, of course. There's even such a thing as a two-dimensional array. And what do you use a two-dimensional array for? Well, think of a spreadsheet where you have rows and columns of numbers. In a two-dimensional array, it's not just one list, it's a list of lists. You have rows and columns in it. So let's print a little table. I'm going to change length to 5. I'm going to change width to 5. And my loop's going to look a little bit different, but it's going to look very similar. For int r is equal to 0, r is less than the length, r plus plus. For int c is equal to 0, c is less than the width, c plus plus. Now int x is equal to r times c. Then let's print that out at that position. C out x followed by the tab. And then after that inner loop, we're going to hit the return key by doing indel. That should print a little table of the multiplication values. Except I got an error. That's probably because I had the program already open. Alrighty. There we go. Well, something's broken. Nah, maybe it's not broken, but I probably should have started at 1 rather than 0 to make the loop look better. So I'm going to change it so that instead of starting at 0, it starts at 1. So r is equal to 1, c is equal to 1, and instead of making r is less than length, I'm going to make it r is less than or equal to length, and c is less than or equal to length. That'll just make our little multiplication table look a little bit better. There we go. So 1 times 2 times 2 is 4. 3 times 4 is 12. 5 times 4 is 20. 5 times 3 is 15. There we have a little multiplication loop. And you can see how it works. We have an inner loop. So the first thing that happens is r is equal to 1. And then it repeats this over and over and over. 1, 2, 3, 4, 5. When it's done with that loop, it prints an end of line to go to the next line. And now r is equal to 2. And so it counts again. 1, 2, 3, 4, 5. And it's printing out 2 times 1, and 2 times 2, and 2 times 3, and 2 times 4. So that's why it does 2, 4, 6, 8, 10. It gets to the end of that inner loop. It prints out another end of line. So we're on the third line. R gets incremented again. So now R is equal to 3. And then the inner loop counts again from 1 to 5. So we print out 3 times 1, 3 times 2, 3 times 3. And so on. So that's why it says 3, 6, 9, 12. And so on. Then R becomes 4, and it runs through it again. And then R becomes 5, and it runs through it again. And then once we've exceeded the length of it, we fall out of the loop. So that's the idea of a nested loop. And you can nest loops inside of loops inside of loops. You know, if you were doing a three-dimensional chart of some kind, you might, you know, this one was only 2 dimensions, so we had only one loop inside of another. If it was a three-dimensional thing of some kind, then you might have one loop inside of another inside of another. You don't necessarily have to have typed that in, but if you are typing it in, if it's not working, let me come help you. Raise your hand. All right. The code that we typed in on page 65 is an example of a nested loop. The outer loop counts per student. Student number 1, student number 2, student number 3, student number 4, student number 5. The inner loop counts the number of exams. Test 1 for student 1, test 2 for student 1, test 3 for student 1. When we're done with the inner loop, we iterate the outer one again. So now we're on student 2. Test 1 for student 2, test 2 for student 2, test 3 for student 2. We're done with that loop, we come back here and we do that again. So the inner loop goes through all repetitions for every repetition of the outer loop. The inner loop will repeat over and over and over until it's finally done, and then the outer loop will click 1, and then the inner loop will go and do it again. So the inner loop completes sooner than the outer loop. When we were running this, the inner loop had to print all 10 of those asterisks, and then it was done, and it was time for the outer loop to do another iteration. And the total number of repetitions is the number of the product of the number of repetitions of the 2 loops. So since this was a 10 by 4 rectangle, and this one iterated 10 times, and we had 4 iterations of the outer loop, that's 40 total. 10 times 4. This one had 4 outer loop iterations, it had 5 outer loop, 5 inner loop, and so 5 times 5 is 25. 25 iterations total, and that's why we have 25 places in our little grid of numbers here. Using files for data storage. This is very important, but we will save that for next lecture. Okay, so what is our homework assignment going to be? It's going to be very similar to our rainfall. Homework assignment. Write a program, and it's going to be another grades program. Yay. That will allow the storage of 10 first names and 10 test scores. Then prompt the user for the name and the test score. Then print the average, or then print them out. Then print the average. So the way it needs to run is something like this. Enter grade, or enter student 1, Eric. Enter test score, 100. Then enter student 2, Sue. Enter test score, 102. I got some bonus credit, and so on, all the way to the end. Enter student 10, Sam. Enter test score, 90. Then it's going to print out a little table using a tab. Eric made a 100, Sue made a 102, Sam made a 90, and the average was whatever those 3 numbers are divided by 3. Let's make it easier to calculate. 60, 90, and 30.
Are we supposed to do a file like we did for the birthday files?
Pardon me?
Are we supposed to do a file like the H file? Like we did for
You
birthday?
don't have to do a header file unless you want to. It's good programming, but we haven't written any programs which don't work without one. So we'll get to one where you have to have a header file in order for it to work. It's called when you create a class. It'd be even nice to write out the names of the number of the students, like that. And then we'd print out the average, whatever that is. In this case, the average would be 60. Like that. So this is sample input and output. I'm not giving you a lot more details than that because you already know how to do it based on the rainfall program, pretty much. Except we're asking for 2 bits of information. We're asking for the student's name and we're asking for their score. So you're going to need a for loop and you're going to need 2 arrays. You're going to need an array of names and an array of scores. If you want the tests to be labeled 0 through 9 rather than 1 to 10, that's okay. And what is it called if you have 2 arrays where the data is thematically linked by the index number? Parallel array, yeah. You could make it so that you ask for the number of names and ask, you know, but don't have to. I would just hard code it to 10. Alrighty, so that's the homework assignment. And then I'll just put a note. This is very similar to the rainfall in class assignment, except it asks for the name as well as the score, whereas rainfall displayed the name of the month and asked for the number. All right, something we haven't seen in the loop. 2 words, break and continue. Let's put these in as notes as well. Break bails out early of a loop. Continue causes the loop to repeat early. And I'll show you what I mean. Suppose I do this. While, or let's declare a variable, x is equal to 0. While x is less than 10, cout, enter a number, and we're going to do some dumb stuff. If they enter a -1, we're going to break the loop. So if n is equal to -1, we break. That means we exit the loop completely. Then we're going to do something else dumb. If n is equal to 2, we're not going to do anything. We're going to just print skip processing. Otherwise, we're going to do something else. If neither one of those are true, we're going to have some kind of loop that counts up to n and, you know, prints out that many asterisks. For int x is equal to 0, x is less than n, x plus plus, cout that many, cout that asterisk, cout an end of line character, and we're done, except I put that wrong. Okay, I'm going to make this a little bit more concise by moving the opening braces up on the same lines. There we go. Okay, so what break does, this loop is going to repeat 10 times. But if they type in -1, it exits. It didn't repeat 10 times, it stopped. It's like a return statement, but a return statement exits a function completely. The break just goes to the end of the while loop and picks up from there. Continue, on the other hand, sort of like break, except it just runs back up to the top. I forgot to do x is equal to x plus plus. Let's tack that on here. I should have made this a for loop. That'd be better to use illustration. For int x is equal to 0, x is less than 10, x plus plus. All right. So let's go ahead and run it. Enter number. 1 is a valid number, so it prints 1 star. Enter number 10. 10 is a valid number, so it prints 10 stars. It's going to repeat this 10 times. Unless I type in a -1, which causes it to exit early and it starts doing all that other stuff. So that's what the break does. It exits the loop early. It didn't count all the way up to 10. It just aborted it at that point and then went to the first statement after the loop, which I could put as a C out, something like that. Or pause, X system pause. All right, now let's try it with 2. Okay, so enter number 0, we're going to print out 5 stars, we're going to print out 50 stars. Now we're going to type in 2. 2 is our magic value that causes it to skip processing. It didn't do anything. Why didn't it get to this point? Because the continue statement made it jump back up to the for loop, the top of the for loop. That's the difference between continue and break. Continue means I don't care what else is in the body of the loop, I just want you to go back up to the top. Rewind up to the top, increase x by 1, and then go for it. Whereas break means exit the loop. Go down to the first statement after the closing brace. Let's paste this into our notes. So what does break do? Break exits the current loop. The program will then run the first statement after the closing brace of the loop. Continue causes the loop to repeat, ignoring the code after the continue statement up to the closing brace. So in our code here, continue caused it to ignore all of this if we hit it, if n was equal to 2. So it went back up here. Hope that's clear. All right, we're pretty much done with the loop chapter. We're going to have to go back and do file I/O because for some reason that's mixed into the loops chapter. So on next Monday we'll do file I/O. Let's go back and see if there's anything more we want to talk about arrays before we call it an evening.
Do you want to upload a Dropbox?
Yeah, let me make a Dropbox so that we can be doing that while. So rainfall goes in Dropbox J. The homework about the grades will be homework assignment number 8. Grades array. I will upload a cleaned up version of the instructions. And we'll make that one due Tuesday of next week. All right. I'm feeling like We may have hit saturation in our brains. Kind of feels that way to me, like we've covered two very different topics and we want to stop. At least that's my opinion. Is it okay with y'all if we leave 20 minutes early, or we want to keep plowing on to get your money's worth?
That's good.
I think we're okay. Okay. All righty, gang. So I will see y'all next Monday. Remember, no class Wednesday, but that's just in this class. If you have any other classes, you're supposed to be here.